also from Switzerland. So I represent Office for Promotion of Industries and Technologies. We are based in Geneva. We work with Western Switzerland. And I bring a revolution, Revolution 4.0. This is I think the topic of this session today. It's manufacturing, robotics, and we are in this context of the Industrial Revolution, Fourth Industrial Revolution. And my office is at the core of this revolution in Western Switzerland. Nowadays, it's all about, in business, about value creation. This is very important, and mostly for successful startups or industries like my colleague here. Let's watch a video of World Economic Forum. They know what Fourth Industrial Revolution is about.
It's a fusion of the physical, the digital, and the biological world. It's changing not only what we are doing, it's changing who we are.
It's really the notion of digital technology pervasively impacting every walk of life and every vertical industry on all parts of the globe.
Whether it's information technology and the acceleration we see in artificial intelligence, a lot is happening.
Society and how we're going to live is being defined right now.
The speed is mind-boggling. What I'm particularly concerned about is how little the world is prepared.
Harnessing this revolution requires the involvement of all stakeholders, from public and private sectors to academia and civil society. The World Economic Forum Center for the Fourth Industrial Revolution Network ensures that the development and application of emerging technologies benefits both people and the planet. It is a network of centers for scalable impact, with locations in the United States, Japan, India, and China, bringing together stakeholders to identify the impacts of these technologies, co-design innovative governance protocols and policy frameworks, and pilot them with partners around the world.
If we are not innovative, if we're not creative enough, it will be very difficult to survive in this century.
Humans and machines are assisting each other, augmenting each other with skills.
Humanity itself will be changed with this superintelligence, and we are at the doorstep of that era.
The technologies available today will impact and change healthcare forever.
52% of the encounters with our primary care physicians were handled virtually. Just a massive change.
Mobile platforms will define how fast Industry 4.0 will be embraced by the countries. The value that can come out of it is unprecedented.
The network will work closely to share research, analysis, and learning, and help design new technologies in ways that respect societal values.
It's where innovation is happening about how we guide this revolution.
We can solve the many social issues through the digital technologies.
My hope is that we have a robust discussion for how this can truly help our world solve some of the hard-pressed challenges that we have today.
Together, we can shape a future that truly benefits and empowers people.
The world has changed. We can never, ever go back to yesterday.
Okay, I'm not promoting the World Economic Forum, but they certainly know what Fourth Industrial Revolution is about. We are in this revolution. We have to seize the opportunities, but there are also challenges. And I wanted to say, like, the main message I want to convey probably today is this revolution is not only technological. There are other pillars, and I'm going to talk about that. It's about employability. It's about a new way of society. It's about new ways of organization. It's about environment also. Okay, it's not only technological. We are really there. Challenges, organization and culture. So we have new ways of organizing business. We have agile method, lean. Now it's all about value creation. Before it was more about performance, perform well. Now it's what does it bring? What value do we bring to society and to our clients? we live in a world that is hyper-connected. And when I'm in a bus and I see people with the mobile phones, I see this is not the same as 10 years ago or even 5 years ago. It's really, we have information flowing. Now it's about seizing the good information for us. We are overflowed with this. Exponential progress, meaning because of this hyperconnectivity, and we have several technologies that are being developed in parallel, and they reinforce themselves in a way that is exponential. Actually, we have the impression to be on a change that accelerates itself. Every year we have the impression that there are more things that change. I work in data science. I haven't presented myself well enough. My background is technical. Data science is the science of people that leverage data for business. And every year there is new software, and I have to keep track, and there is some point it just gets very difficult to keep track of all the innovations. Use-based economy, so is really consumption. So this is the paradigm right now. And hyper-concentration, meaning in order to survive in this very competitive environment, business have understood that sometimes it's good to aggregate, like Silicon Valley, like startups in Israel, in major cities. They have this pole of innovation. And then the opportunities. And here I'm going to talk about these pillars. For us, Revolution 4.0 means lean management, means sustainable development, technologies, industry 4.0, employability, new skills. People have to develop, have to adapt. It's no longer about doing routinary jobs. It's about creating. It's the power of human values. The rest is the machines that will do. We will get the best part, hopefully. This is the opportunity, right? And Society 4.0, meaning we will have probably new ways of contract. Is the jobs of the future, the jobs of our children, will there be of the same kind, or will they have 4 jobs simultaneously? Or like 20 years ago, 1 job for 30 years? Things change.
Or no job.
Or no job. Before, we had, for the most, there was a model where you had, you had a big factory, and then you get your products to the clients. Now you try to have delocalized structures, but this we'll talk later about additive manufacturing, for example. I have many slides, so I'm gonna flow quite quickly. Now let's talk a bit very quickly about technologies. So we see the new people in the world, these robots that are coming with us. We have robots, we have, maybe you don't know the vocabulary, sobots, the ones that it's like pet, the robots that are there to, like your dog, your cat, to make your life a bit more funny. And you have cobots. So cobots, they work with you, they learn from humans. So this one, for example, is a Swiss industry, ABB, international, and you train the robot to help you do the routinary tasks you don't want to do. You want to do the creative part. That's the new skills.
Can you take a picture? Yes.
Let's watch this video. I think it's interesting. coming. So get ready for that. Be creative. Other technology, additive manufacturing, we'll have more later about that. Vladimir's gonna talk. I have a nice video from Adidas. If you
see that.
Later.
You'll turn on while I'll be speaking.
Well, you're right. Maybe we can see. Okay. So just a trailer of what comes next. Okay. If I can. It's Adidas. It's fun.
Welcome to Carbon. We're a technology company changing the way the world makes things. Specifically, 3D printed things. We didn't start out trying to change manufacturing forever.
We didn't?
No, we didn't. We started with the simple goal of making 3D printed parts better.
It's 25 to 100 times faster, which is game-changing.
But we quickly realized that with our combination of technology and materials, we could make real parts with mechanical properties and surface finishes that make injection molded plastics obsolete by comparison. Embracing the idea that speed to production isn't an obstacle anymore. It's the only way forward. And our partners share our enthusiasm for reinventing the rules. Partners who are manufacturing at scale, making millions of real products.
Like us?
Yeah, like you. In partnership with Adidas, we've created a midsole that shouldn't exist so that they could make a shoe that shouldn't exist. Light, super flexible, highly durable, and printed straight from liquid. A marvel of design and function, this shoe defies logic. And whether you want to make 1 or 1 million, this is true, customizable, and on-demand mass manufacturing. This is not a publicity stunt. This is a revolution. And we're just getting started. Stop prototyping. Start producing.
Wow. So new opportunities for industries. Then there is all the aspect of artificial intelligence, meaning we can train machines to understand certain human concepts. Like, for example, we can train them to recognize in images, recognize objects. And we'll talk later about that because it's used in industry for detection of defects. So here we can predict in the photo where there is a motor, a bus, a car, with several techniques, and the most advanced is called deep learning. We have data is becoming very, very important. You know that because of the Google, Facebook, and all these issues about data protection. Maybe we'll talk about this. And there are two approaches to data. One is from taking really from the data, like I collect data and what can it give me? And the other is I have a vision, I have a business case, I don't know, I'm Google and I want to seize the world. I have a vision and then I try to get the data that helps my purpose. So both approaches have to be in synchrony. And yet another technology that is coming, and I'm not being exhaustive, but certainly this one is a big hit, blockchain. And in one sentence, blockchain, it's going to allow, so before we had centralized institutions that provided trust. So, for example, money, the trust comes from governments, and now with blockchain, trust will be able to come from a community. A community will be behind trust instead of a centralized institution. So it's also about democracy. It's very interesting, blockchain. And let's not forget one of the biggest challenges facing us is global warming. So with this revolution and with all that's coming, we have the opportunity actually to do business on that. We can do business on climate change. We can do green business. It's really a huge market, real opportunity. And as time, it's one of these investments where it's going to pay off. It's going to be pay off because as years go by, the problem is worse. So it's a positive trend. So it's really a good opportunity to invest there. This is very important in our office, is employability. So now we switch from the technical part to the human aspect. We have already highlighted that the new skills are going to be in the social and emotional, in the technological and higher cognitive, and way less in routinary tasks. Okay, so these are studies that are being made in Mackenzie in this case, and Switzerland makes no exception to that. We work with a professor actually in Geneva that has a very interesting project on how to measure cognitive performance of people, like the skills, and he has 12 categories. He categorized, so I'm going to show you how this will look like. You have this kind of diagram where you represent the different, say, skill set that you have. And let's say you had this skill set. This one is actually from my director of our office. And I have to give credits to him for the nice slides that he has composed. So he's got a certain skills, and for the future jobs, you have to redesign your skills to adapt. You need new skills. And how can you make this improvement? Well, there is a whole field about micro-learning, about plasticity of the brain. It so happens that our brain has way more neurons that we can use, and actually we are incredible in the way we can reshape and retrain our brains. These are studies that show that we have really the potential at any age to change our skill set, to reinvent ourselves. And another pillar, so we have seen the technological pillar, the organizational pillar with the lean development. We have seen employability, the new skills. We have seen environment, and Society 4.0 means what will be the jobs of the future, okay? And this is more, let's say, a government thing and less of something that in business you can manage. But certainly something very, very important for future. So what now? What do we do? If you're a business, you do the strategy of the candle, like with a light. You just, I don't want to know anything about this, please.
Yeah.
Or you're the superhero and you go for it. I guess here we are the number 3. We are in Davos. We want to seize the opportunity. We see that there are major challenges, but we are courageous and we're going to go for it. Okay, so I'm not going to talk much about what we do in general in our office. I wanted to talk a bit about the program of machine vision, because I'm the head of this program for Western Switzerland. So if we could switch the presentation, please. And I'll be quick.
I think you can press text, maybe.
I think they have to change.
Yes, okay.
Yeah, because it's another.
Yes, okay.
Yeah, so machine vision is vision made by machines. So for the first time in history, you'll have, apart from an image acquisition system, so very, very advanced image acquisition that really puts defects in perspective. So we are talking of an industrial context, we are talking of production, so for example, of your watch, and you want to see the defects on this watch, and you want to do that by machines, okay? First thing, you have a super powerful camera with new technologies. For example, you have, Keyence has developed a multispectral acquisition system where you have several radiation lengths that impact on the product, and they show you different defects depending on the wavelength you use. We work, by the way, with these providers. That's why I showcase them. You have 3D systems that allow to take 3D images of your piece, of your product. And this is the new part. This is the intelligence that comes. So the machine is going to act, is going to, for the first time, understand in a way what's on the image. We are going to train the machine to see defects. We have to show them a certain number of pictures, and the machine telling, for example, this watch is okay, this watch is okay, this watch is okay, this watch is not okay, here there is a defect. And then the machine will understand and will be able to distinguish between good and bad. And we have a very interesting provider, Cogito. You can see this picture at the right. They have a package. It's a small case, and you have an intelligence there. You can pretty much interface that. You can do it with cameras, but you can also do with audio. You could do with any acquisition system. Any kind of signal, you can plug it there, and you have an intelligence that you train, and then it gives you back results. These are our technological partners. So now our aim is to have new projects and to advance these technologies for small and medium enterprises. This is our role in Western Switzerland, to promote these small medium enterprises together. And we work also with Canton de Vaud, Canton de Neuchâtel, and in general in Western Switzerland. Okay, so this was all from my side. Thank you.
Cool, thanks. I think I will be the next one. I want to say thank you to the previous speaker for covering almost everything on the manufacturing 4.0 and the revolution in manufacturing. My name is Vladimir Rousseff. I am the CEO and founder of the company with a strange name, Kwambio, which is a 3D printing company focused on ceramics and composite materials, powders and materials that didn't exist before. We're developing them. And I am originally from Ukraine, so I know pretty much about revolutions and how they're going, how much time they take. So when we're speaking about manufacturing and revolution in manufacturing, and additive manufacturing as one of the main forces behind it, I should say that it's one of the slowest revolutions maybe in history, because the first 3D printing technology was announced in 1984. I was born in 1983, only 1 year before it started, and still we're talking about the revolution connected to additive manufacturing. But it's actually true, because every year, every 6-5 months, we see some new cool invention that helps industry and companies and business to move forward. As every technology, additive manufacturing and 3D printing go through this Gartner cycle with the hype and then going down to the death well, and then the real business starts. That's what happened to 3D printing in 2015 and 16, when everybody was talking about that 3D printing can change everything, that we'll have 3D printers at our homes, living rooms, kitchen, printing pizzas, clothes, everything. And I was one of those guys who was traveling from MIT to Harvard to Techstars, talking all that bullshit about 3D printing. So I'm sorry for that. But still, we have pretty much progress on 3D printing that I want to share with you guys here. I don't have slides, but I will tell something I'm doing in my business and how I see other businesses connecting to this topic, so maybe it will make some sense. Maybe we'll start with what additive manufacturing is and how it's different from traditional or subtractive manufacturing. I think that's a huge difference that makes 3D printing and additive manufacturing like standing alone and being so big and having so much impact now and even in future for manufacturing and how we live and how we see things. First of all, subtractive and traditional manufacturing is something very close and natural to creating waste. Because what is subtractive? You cut something you don't need, and then you leave something you need. So you're creating waste much more than the final product you have. The additive manufacturing is the opposite. So from the beginning, you see the shape of the object you want to create or a product, and you're creating it without waste or close to zero waste. So in global perspective, it's another kind of approach we're used to create things and to consume things. And also, it's quite different in the method and approach of how we manufacture and how we consume the products we used to consume every day. Because when you're talking about traditional manufacturing, the specific of technology makes you go to vertical integrated manufacturing. So we have that huge gigafactories in China or in other countries, and then you manufacture millions and millions of the same products, and then you move them globally, I think, moving them from one continent to another, and that makes also a lot of waste around it, a lot of costs, a lot of people are, from one point of view, involved in that, from another point of view, are struggling with that. So what's cool about additive manufacturing and 3D printing is that you can consume and manufacture locally. So for example, you can manufacture something on your 3D printer, and then you can consume it. So one of my biggest ideas when we started our 3D printing companies in 2015 was to create this kind of a network of small local factories and go from the vertical integrated global manufacturing to local manufacturing and horizontal integrated manufacturing. And we had an idea to create something like an app store, but for physical objects, that we actually launched in 2015. The idea was that I came up with a cool design. I live in Japan. I uploaded it to this app store, and I'm the guy who liked the design. I want to print it out, and I have a printer, and I live in Switzerland. I push the button, and I print the product. And when I printed it, I pay money. I'm charged for that. The cut of the money goes to the designer, the cut to the platform, or to manufacturer who manufactured it locally for me. So it's kind of a horizontal system, and everybody benefits of it. So kind of elegant model, and I liked it very much, but it couldn't catch up with the technology. Still, I think that's a good concept for the future, and I believe strongly that we will achieve that in maybe 10, 15 years from now, because I think that...
is it called cloud?
Yeah, actually we're using cloud as a source for the design and for connecting consumers with manufacturers. Yeah, so technically it's a cloud manufacturing. But the issue was that the technology and the 3D printer that already have been developed can print you Yoda hat or some stuff like toys or do-it-yourself things, which was pretty clear in 2015. Now we have nice progress on different type of materials like metal, like ceramics, like composite materials, and going from consumer segment to the industrial application to the healthcare industry. And the main crisis in additive manufacturing and all that hype around was connected to the belief that in 2 years, everybody can print everything using a small machine like our computer. And a lot of scientists and opinion leaders were comparing additive manufacturing and the cycle of its development to the PC market and how it evolved in the 1780s till 2000. But it's not like pretty correct, because quite different technology. And what's interesting about additive manufacturing, everybody should know, start dealing with that. There's no one standard for 3D printing and additive manufacturing. No one core technology, no one core 3D format files. It's all different. I think that under the umbrella of 3D printing and additive manufacturing, we can now count like tens and maybe hundreds of different technologies which have the additive nature of manufacturing. But what we were doing, what problems we were solving for our customers, starting from 2015, we figured out that if that approach when you can print everything using your home printer wouldn't work for at least 10 years, and we as a company, as a business, need funds to make it happen, and we want to work with the real demand, with the real inquiries for real businesses globally, we should find that niche or that opportunities where 3D printing can already benefit for the real businesses. So we were looking for type of materials we can work with and with technology, which will suit this and fit this type of materials. And we actually came up with a binder jetting technology for ceramic powders. It's a complicated sentence, but actually we developed a technology that lets you print finished ceramics objects, and then we made even step forward, figure out how we can create new composite materials based on ceramics. Imagine that you can connect in one material ceramics, glass, and oxide of aluminum, so you can print a cup, and you will throw it on the floor and you will never break it. And that's kind of a thing that when we offer our customers or businesses, they are not quite sure that it works, but when they see it, opens their minds and they can think about new opportunities and new applications they can work on with understanding of how new materials can work. Because for now, they live in the paradigm where they use the same materials for hundreds of years, and they got used that they can do this type of products with that. But now, when the additive manufacturing and manufacturing 4.0 offers new type of materials, new approach, new timing, new cost structure, they can think really of a new type of application. And I think that in 5-10 years we will see the results of this shift in thinking. Because our company, Kwambio, we were part of a Techstars accelerator in Boston and then in Connecticut with a company which is named Stanley Black & Decker. It's the biggest manufacturer of tools and different instruments in the world. And they used to some processes with dwelling, connecting metal rods with metal sheets under super high temperature. And like for 75 years, they're manufacturing special ferrule ceramic rings for that. And actually, they spent about 2-3 days for developing one ring and then 2 weeks for manufacturing a small portion of that rings. What we offered them, you can now print 25 rings per hour. So it reduces dramatically the time and the cost and the amount of people working on that applications. So at the end of the day, the department where about 45 people worked on that. Now they have 4 people and 10 printers, and they are more efficient than they were before. And those people, I don't know, what are they doing? Maybe they are doing another job at the factory.
They got creative and hopefully they find and now
actually from what I've seen,
that's a big
they
point,
didn't
actually,
look too creative. Also, the big issue on the big companies when you want to innovate and you bring kind of a solution that solves problem right here and right now, a lot of people are not ready to implement it because they understand that maybe your solution is pretty good, so their job wouldn't be in a big need tomorrow after they will implement your innovation. So that's kind of a natural conflict that lies between innovating and manufacturing 4.0 for the big traditional organizations. So I think that's something executives should also have a real good strategy on, because if they think that the people on the middle level and on the lowest level will be happy to innovate using all the technology they can get, not so true, even in Fortune 500 companies. So that's where we should find a good approach. And I think that the good executives there should invent new jobs for their staff who already have good experience and good traction in their company. But returning to what we can do with the additive manufacturing, how it compared to traditional, I think that the additive manufacturing is not killing traditional manufacturing. You have a good slide with the candles. I think that candles are still on the market, and we all use electricity, but actually a lot of people like candles and they're using and they're buying it. And there are companies who are making $1 million on selling candles in 21st century. So I think in our time there is space for everyone, for every business, for every application, the newest, the innovative, and which we consider not so innovative right now. Maybe 3D printing in 50 years from now would be something like candles today. So we should be ready for that. And
so certainly, I think one point of discussion probably would be about what are the new jobs that are being created and what are the jobs that are...
Yeah, absolutely.
That's one point.
The best way to be prepared for a new job, to invent the new job.
Yeah. I was curious because I know you work with very big companies like I think General Electric, and I wanted to know like what potential do they see in your...
But maybe we should open the discussion after the...
Yeah. Okay, I will finish about the description of that. So additive manufacturing is good based on the technology side for manufacturing small batches of products and one-of-a-kind products. Because if you need millions of products, the old good Chinese factory will work better than any 3D printer on the market. Even those guys with Adidas and Carbon, the movie is pretty cool, but not so cool in real life. For when you need like high-end design products and you need 5 of them or 10 for a gallery or for Cooper Hewitt Museum, that's the best way to use 3D printing. But when you need 2 million of cups, you should go to the traditional factory, it will be much cheaper.
Yes.
For companies like GE, like General Electric, when they need new type of applications, they want to test and they need small batches of super high complicated geometry shapes with the complicated internal structure, that's where 3D printing...
Then you're there.
Yeah, so we manufactured for them special units for electronic devices in special ceramics with high conductivity properties. Also some molds for casting turbine blades with a high-end...
Just a question of how you structure it. Should I ask question later on or probably now?
Yeah, I think that we will have questions after we'll finish with the talks.
The better, it's better.
Okay. Yeah.
So you want to finish or?
If you let me finish, I'll do that.
Okay.
Okay, I'm almost finishing. Actually what's cool about 3D printing that it gives you a new approach and new point of view for the products that you couldn't consider actual products, and you couldn't consider the process of creating it, manufacturing, but now you can. I'm talking more about the healthcare and bioprinting and printing bones, because we developed 2 biopowders which let you print bone structures which are organic. And actually, they're 99% the same chemical structure that our organic bones we have in our body. But now imagine that you have a digital platform like your iTunes account or Google Drive, where you have your photos, videos. Now you can have your personal account where you can upload your MRI, 3D scans of your bones. And when you break something, you can go to certified clinics. They will use the technology to print out the broken bone, implant it, and you're all set. So you start thinking about your bones and organs as the spare parts, and as the products we can manufacture. Not traditional way, but additive manufacturing. So everything inside that, almost everything, can be manufactured and will be manufactured. So I think that the biggest advance of manufacturing 4.0, that we are not just changing the way we manufacture, but we're changing how we see what we can manufacture and what theoretically can be manufactured. So I think that the biggest advantage, that shift in how we see things, how we see we can manufacture and also consume them. And that's also a big issue for companies who used to use the same technologies. They're evolving small companies, startups, who may be more efficient using the new type of technologies. And this kind of collaborations, I think, very important. Because in the United States, where we have our target market and we focus on East Coast and New York, Massachusetts, a lot of big companies, they establish the acceleration programs with accelerators like Techstars or Y Combinator, where they open their doors to the startups. We're coming, we're looking at the issues and the problems they have and try to fix them with the new technology we developed. I think that's a really smart approach that's being used by US companies, not so much by European companies as they see it now, but I think that's a trend that we'll see next years also in Europe. So actually that's what I wanted to say.
A specific question.
Yeah.
What are kind of physical properties of kind of 3D composite you are producing, like thermal resistance, for instance?
Actually, for the ceramics we use for high resistance temperature application, it's more than 2000 Celsius, which is pretty more than traditional ceramics. And what's even better, we can create materials on demand based on the applications our customers use. Maybe you meet the part that we can connect like oxide aluminum with glass sphere, with ceramics, with the biopowders, and connecting the different materials in one powder, you can get new type of properties. What they can be, that's we don't know until we invented that. Actually, yeah, there are companies who are working with it. We are more focused and more specific with the ceramics and ceramic-based materials for the healthcare, aerospace, for design and art industries. We're for now not using graphene, but actually, who knows? We're more about powder materials, so maybe we'll create some powder based on this type.
Okay, thank you. Yeah, my question was because we're also considering some like hypersonic applications, and this thermoresistant materials is actually key for constructing this.
Yeah, absolutely.
Yeah,
and what's cool for companies like you, or what for the application you work with, if you want to get the final product or a prototype, it will take you like 2 days, 3 days, and you have it, and you can rework it, and like in 2 weeks, you'll have 5 cycles of finished products. That was impossible like 10 years ago with traditional manufacturing.
Okay, thank you.
Thank you.
Okay. No. So okay. Okay. It's going to press again? Huh? I have to press again, or? Yes, okay. And then back. Okay. So thank you for the invitation. Now I will talk about a rather provocative topic, which when it started to be discussed, I would say roughly 2 years ago, created a lot of turmoil, and it's still very controversial. But I think it's interesting at least to think about it, and also taking into account your presentation, where you talk about the future of jobs. There are a lot of uncertainties about this. So I will try to describe to you some of the solutions if we really have a problem with the development of robots. To add, is it like this? No. Yes, okay. So, as you've seen, when we speak about robots, we've been using a robot since quite a long time already, especially in the industry. Now, I would say in all car factories, 80% of the job is done already automatically by robots. But the key question, I think, is that we see now more and more robots entering also into the service industry. We see robot doctors, bankers, entertainers. You may have seen on YouTube that I played the electric guitar with a robot who was really playing the electric guitar. He's not yet really creative, but he can play. He had a peak, and it was really a starting point. You see a lawyer, there's the famous Ross. Ross is a research tool, and just by chance, he's specialized in bankruptcy law. So it's interesting to see why they chose this topic at the beginning, this area. You see also, of course, robots in the administration, agriculture. In Japan, I saw, for example, one prototype of a robot which would help people to fill their tax return. So it would show exactly where you have to fill the blank, etc. I hope it doesn't make any mistakes with the figures. Yes. So the problem of this development, of course, it's quite interesting, and robots are now also doing tasks that are dangerous, that are boring. So it's a great development, and also for doctors, for example, in some cases, the diagnosis by artificial intelligence was better than a human diagnosis. So, of course, I just don't want to show today that I'm against the development of artificial intelligence and robotics, but there are some risks also linked to that. And the problem is the following, is that you have two schools of thought, basically, if I really summarize, on the development of robotics into the labor market. You have the optimist on the one hand, and I must say, I think the WEF is rather on the side of the optimist, even though it's also controversial here, but you have the pessimist. So basically, there are two schools of thought. The first school is to say, well, this is the fourth industrial revolution, as you've described. We already had 3 industrial revolutions, and it was fine at the end of the day. Even the general situation of the people got better. some jobs disappeared, but new jobs and more new jobs were created. This is what Schumpeter calls the creative destruction. So this is the optimist. They say, don't worry, you have to adapt, but everything will be fine, and there are going to be many more jobs. So we should not worry. Okay. Now you have the pessimist. So the pessimist, they say, this time it is different. Why this time is it different? Because this time the robots and artificial intelligence are designed to replace the brain. So not only the arms of the people, like the workers in a factory, but the brain. And eventually, we don't know when, but it's possible that in the future, this brain is going to be superior to the human brain. So why isn't it possible that any jobs, in fact, in the future, are in danger? So, well, frankly, I'm not arrogant enough to tell you that I'm going to tell you which one is right or wrong. Nobody really knows. But what we should know is that at least there are some risk, and clearly notified even by a Nobel Prize economist, there's some risk that many jobs are at danger. And frankly, if you think about it, even in your slides, you discussed about the adaptation skills. And I'm not quite sure that everybody will have the possibility to adapt, and to adapt on time. I mean, if you are a worker in a factory, it will take quite a long time to become a computer coder, for example. So some people are really going to be in trouble, and this is for sure. And if the pessimists are right, this is a problem, because we have a triple negative effect. First of all, the labor income will shrink, if not disappear. And if you think about it, the labor income is the income tax, but it's also the base for the social security. So the second impact will be that not only the state will lose the base of the income tax, but they will need to pay additional funds for the people with no work, no jobs, so unemployment. And the third one is also quite problematic, is that if people have no money anymore, they will not consume, consumption will go down, and this is not good, of course, for the economy. So again, I'm not in a position to say that this will occur, but I think if you are a policymaker and there's a risk that this occurred, you should also at least think about it right now, design some alternative solution, and perhaps we won't need them if the optimists are right. Okay, at the same time, it's interesting to see that another line of thinking has developed in parallel to this concept of the robot tax, is that also a rather revolutionary approach, which started at the EU Parliament in 2017. There's an EU report about this, which was to grant maybe a new legal personality to robots. This was quite controversial, of course, at the beginning, but when you think about it, it's not so silly. 1 century ago, you remember that we created, it started in America and in England, rather at the same time, they created the concept of a legal entity, a corporation. I mean, what is a corporation? Have you seen a corporation? Have you shaken with a corporation? No, a corporation is just a legal concept. It's a legal fiction. It's one day, the parliament says, this entity with this feature, I'm going to grant a legal personality, and it's going to be a corporation. And a corporation, it can be sued in court, it has a right, it has obligation. So why not develop the same concept? Maybe the time has come, maybe it's a bit early, but maybe the time has come at least to think about granting a new legal personality to robots under some specific feature, and this is what the EU Parliament has done. But at the end of the report, they decided not to go ahead. But at least the studies is going forward, and many scholars are making a lot of research, and I published many articles about this issue recently. So Estonia, for example, has also created a group, and they are thinking about creating a legal entity for robots. Now, when you start to think about granting a new legal personality, if I may quote the Beatles, you may say, here comes the tax man. Because what happened when they created the corporation? Soon after, they introduced the corporate profit tax. Now, if you start to think about a robot as a legal entity, you may go a step ahead and say, well, maybe we can create a robot tax. So why not, in fact? And again, I stress this only in the case that the pessimists are right, not if the optimists are right. If the optimists are right, we don't need the robot tax because there will be enough jobs. So in order to introduce a new tax, of course, you need a justification. An economic justification and a constitutional justification. I will not go into details on that, but the economic justification could be the following. Let's say you are a company, you are hiring robots, you are using robots or even artificial intelligence, and you don't hire any human workers at all. Well, in fact, you don't pay a salary anymore. So you can say you have a sort of economic advantage because you don't have to pay a salary and you are using robots. That's one economic approach that some people are taking. The constitutional perspective is a bit more problematic because when you raise a tax in any countries, you need to respect the so-called principle of ability to pay. I mean, you pay an income tax because you have an ability to pay. You have an income. You pay the value-added tax because you have an ability to pay, which is the amount you pay to purchase a goods or services. The rate is fixed for some. Yeah.
Means that this corporation has to pay tax not because of like revenues, income, but
yes,
percentage, for instance, you have fixed.
Yes, or like a wealth or capital.
Yeah, but for corporations, it could be like machinery.
Yeah. Yes, but still, it's also a feature of a sort of ability to pay because you have assets. Yeah. You know, it's not as perfect as an income, but it's also a feature of an ability to pay. You may say. The problem of robots right now is that they don't have an ability to pay. A robot has no money to pay the tax. So this is one of the main problems of starting to introduce a robot tax is because so far robots, they don't have any ability to pay.
But if robot doesn't pay, what government can do? I mean,
well, what they can do, this is my point, they can start taxing not the robot as such, but they can tax the use of robots by companies. So this would be one of the first approach, and maybe in the first step, to say, okay, we are going to tax not the robot as such, because they don't have an ability to pay so far, but we are going to tax the corporation using robots instead of workers.
So kind of owners.
Maybe let me finish the presentation and then we open the discussion. Because some of the questions I will cover, I think. Yeah? Okay? So, how to implement it? This is just some ideas. Huh? Of course, we are not here yet. No countries at all has introduced a robot tax. It's mainly scholars who are thinking about it. Just to tell you clearly what happened in some of the conferences I made, I even received some insult. Huh? So 2 years ago, so it was very controversial. And right now, the reaction is quite different than it used to be. So one solution would be to introduce a tax at the level of the corporation using robots. South Korea, for example, is starting to think about it actually, but they want to do it in a different way, is in an indirect way, which is to limit the incentive to use automation. But then it's more a bit like science fiction, but in a second step, you could even consider that if the robot as such becomes a legal entity, such as the EU report is suggesting, maybe they can become an entity with an ability to pay. And some technologies would even allow maybe cryptocurrencies or any other type of money, you could even consider that the robot as such has an ability to pay, but of course in the future, and then it could be subject to some kind of income tax. A very interesting approach to me is the value-added tax, because the value-added tax, you are taxing at the level of the consumption, and you don't have the issue that we are facing with the digital economy right now, where you know that the income tax is in big danger because these giant technological corporations don't really pay the fair share of profit tax. But at the end of the day, you have the consumer. So one solution also would be to consider the value-added tax. Social security, of course, it would be key because this is the main threat of the use of robots. And a last solution, which is more in line of what you were suggesting, but it's looking at robot like a car or like a dog. You know, you raise a tax on robots like a machine. The United States is already doing that with drones. Some of the states in America are taxing drones, and this is like an object tax. So there's some little trends starting here. But anyway, I think it would be quite dangerous for one state to introduce unilaterally this kind of taxes, because it will put this state in a competitive disadvantage. So an international framework would be required at the OECD, at the United Nations, at the EU. At least some global approach, I think, would be necessary. But I would conclude, oh, sorry, I want to go back, this is just the source. But I want to conclude this presentation with a warning. Be careful, because maybe the robot one day will refuse to pay the tax. And even worse, they may force us to pay their tax. Thank you very much.
Thank you. It's okay, we can leave it. Yeah.
Okay, yeah. So I think now it's time we can open discussion, the three of us together. Yeah.
Thank you very much. Very interesting presentations, and Professor Oberson. On this taxation of robot, I think there are kind of two or more layers here. One is more kind of political economy level. Okay, if robots are replacing persons, then probably labor for people could be not the only source of income.
Yeah.
Kind of general income or some other concept. But of course there are some other problems that people kind of could be even degrading probably, because if you do nothing, just getting kind of social payments every month, I mean, it's not good for society. It does not develop society at all.
Yeah.
But I think there is this layer, and there is technical layer how to tax, and there is also, I think, lots of risks here and opportunities. But I think most natural approach would be just tax robots for now as a machinery, as tool. But
yes, so far, absolutely.
But you brought very interesting point. And really, it's important to do it internationally, because if one country does it, it just artificially creates competitive disadvantage. First, in short term, and actually in long term as well, because it reduces kind of a stimulus for development of robotics.
Yes, you're absolutely right. I mean, if really, I don't know, in 50 years, labor really disappears, what will people do? This is also one of the big issue. So ancillary to the robot tax, I didn't mention, but there's also some people talking about the uniform minimum income, which is also in parallel to that. And the people are also talking about maybe developing philanthropy, developing artistic other activities to, or at first stage, at least to collaborate with robots. But this is also a big issue. What will people do? The meaning of life will have to adjust to that.
Yeah, and I think this is the most complicated and philosophical thing. There are some theories, like communism, for instance, which says that at a certain point of development of society, people will not have to work. We should just do something for self-realization, but kind of means for living will be produced by advanced technologies or whatsoever. But it's kind of really very high-level discussions, probably.
Of course, yeah.
Yeah.
Yes. Yes.
Hi, thanks a lot for a great presentation. So there's also a line of thought in taxation now that we should shift away from taxes people efforts as resources to really shifting the burden to the other resources, burden of taxation to the other resources. So use of natural resources, basically, yeah? So what do you think about that line of thought and how that would relate to this topic?
Yeah, yes. Absolutely, the other approach is to shift toward, for example, like the carbon taxation, but this is already implemented. Many states are taxing, for example, carbon. In Switzerland, we have a CO2 tax. But I think our people are talking about taxing financial transfers. But I'm not in the line of some people that say, yes, for example, we introduce, I read, there was, I think, even a professor in Switzerland, he said, you just introduce in tax on financial transfer and you can read all the tax. I don't think so. I think a good tax system is a combination of many different taxes, which should not be high, because they should, as you said, they should let the innovation, they should let the economy go. But I don't believe in the one magical tax that will come and everybody will be fine. I don't agree. And on top of that, this financial tax, it would have to be accepted worldwide, because one state, I don't know, Panama will say, we don't levy the tax, and then all the financial transaction will flow through there. But yes, we should think about alternative, and we should readjust the tax system with the new economy. Of course, natural resource in one way. Also, people are also saying we should shift more labor taxation towards capital taxation. There are many people studying that. But again, be careful about the overall balance of the
ecosystem, the system. Yeah. Yeah. Thank you.
Thanks, Xavier, for the interesting talk. I have a short question regarding the multilateral consensus on this kind of taxation. How far do you think we are away from kind of for nations to come together to see if they can agree a common policy on this taxation? Because it's not something that one country can do, as you say.
Yeah, we are very far away from that. If you see just the EU Parliament, it was discussed at the end of 2017. Majority said no at the EU. And if you, in America, of course, there are some scholars thinking about it, but nobody is really seriously thinking about it. Even though you may know that Bill Gates made a striking interview in 2017, and he was in favor of taxing the robot. It's an interesting interview in Quartz TV in 2017, and I was really happy to hear this interview because, frankly, I received in 2016 very, very strong criticism. Even some, I'm telling you by email, even one anonymous email. I mean, I've never seen something like that. I mean, we are just thinking, it's just. And then I always quote Bill Gates because at least, you know, we cannot say he's not, he's a serious person. I mean, he knows what he's talking about. So at least some major people are now, let's say, going into this line of thinking, but it's more policy makers, not really government as far as I'm aware. So it will take some time, I think. Yeah.
Thanks. A question to Vladimir Rousseff of the 3D printing company Kwambio. Can you elaborate a little bit on how the technology that your company is using, so 3D printing, applies to the healthcare sector, or could apply to the healthcare sector? I think you mentioned bones and some other organs, even a sort of atlas of the human body, spare parts. It's very interesting, but could you maybe say a few words on what exists today and where do you see this in, say, 3 years from now?
Yeah, of course. Actually, we're now going to the clinical studies in Ukraine with this project. The technology is based on the binder jetting. So we're using powder materials, which are organic origins. So these are two types of materials. One is biomodified polymer, and the second is hydroxyapatite, the material our bones are made of. So what's cool about that the technology can give the implant and the graft the right porosity. So when you implant it into the body, your organic bone structure starts growing inside that implant, transforming at the end of the day your implant into your organic bone. So after 5-6 months went and everything is okay, you're getting your own bone based on the implant you got earlier. And your implant going out naturally from your body, and you're forgetting about this. Why I'm so excited about that? Because I did it myself for my hand. I just broke my hand in Texas during rodeo, so it will never be the same again. I have like 3 titanium plates inside, and actually they hurt me every day. So the only option I see is to print out the bone based on my MRI that will fit perfectly, and then I feel that I'll get my real bone, but it will be created artificially, being organic bone structure. That's I think how we can think about our organs and about our body in future. And talking about robots, actually we tried to use some robots, and I remember that old anecdote when the wife of Karl Marx are coming to him and asking, hey, what's happening if all the slaves that are working in our house, all of them will be free? No worries, honey. It won't happen during our lifetime. So actually, how it happened, and for the robots, I know that was a really cool startup which was named Rethink Robotics. This was the first robot that was used on different factors and had the app store with the skills you can upload. And they raised about $300 million. And last month they shut their door because they couldn't compete with the guys from Asia and other countries. Until now, they work better than that robots. Yeah. So I think we're going there, we're heading there, but we're not still there. Yeah. So it's good to have a tax plan when we'll be there, but we have enough time. That's what I see from my business.
But because you see the tax are always in advance.
We have
tax
pretty
people
much
are always
okay.
ready to, if there's something to tax. They are going to be there. Just an anecdote following on what you said. I read there was an hotel in Japan, and the hotel was run by robots. It's called Robot Hotel.
Sobot.
Yeah, I've seen that.
With Sobots, right. Guess what? They canceled the robots and they now hire people again because it's too expensive. Apparently there's always trouble. They always have to be repaired. So it's exactly
it's hard to innovate.
So it's still not there. And frankly, I wanted to go there to this hotel, but it was a bit outside the city. So I could not use it. Now it's a human being. And, so it's the same. Yeah.
I enjoyed the complementarity of our talks and how precisely when I was presenting these 5 pillars, I was saying, okay, fourth industrial revolution is not only about technology, and there is the human aspect in it, and there is this society 4.0, so the new rules that we have to, that we need for exactly this. No, there is this transition. We are having robots taking more and more jobs. New jobs will be created, that's for sure, but what will be the ratio of creation and also all this stress we are putting on people to adapt is a lot of stress. Okay, so again, it's possible to readapt. Our brain is amazing. There is this plasticity that eventually you can learn more about. But for the long run, in the long run, I indeed believe that there is some new structure that has to be taken. And actually I had a question about that. I'm really curious about this minimal revenue. As you mentioned, these approaches like, okay, a minimal set standard for human person, just the dignity of being a human person, and how this really interplays with you. Like, because if you have this minimal revenue, where does the money come from? So
yes, exactly. So one of the possibility to finance this minimum revenue could be the robot tax, because then it's a concept where you have almost not enough job, no more jobs, so people are unemployed. So you don't have the income coming from labor. So then you tax. So maybe you tax also resources. So maybe eco taxes could be a combination of or capital. and robots. So it could be a conjunction. And then I think if you do that, you could even replace completely the social security system with this revenue minimum income. At least adjust it. Yeah.
Juan, this question's for you.
Yes.
I wanted to see if you can comment on, in your machine vision business, how the kind of learning process happens for the AI, and if you're using kind of synthetic data and synthetic imaging as opposed to real-world, images and then segmentation and all of that, and what potential do you see potential in that? Does that work?
Okay. So thank you for the question. We have a partnership with solution providers. So we are the project managers of this. The solution providers each of them have their specific technology. So I cannot, of course, not tell you about every technology that they bring about. I can tell you about some of the most advanced technologies that I have personally experienced. Doesn't mean probably in some laboratory, in some university, there are more advanced trends than what I've seen, but these are like major international providers. And so these solutions you can already implement in your industry. They are there for you, okay? And kind of the state of the art that I've seen is these deep learning algorithms that are very computer consuming and that are trained with real images. You have the product, you take images of it with the same conditions of éclairage, light, yeah. Very reproducible. So you have a system that always shots with the same atmospheric condition, same light, and then you try to have a clear background, so take out doubt. So you have a very nice picture, very reproducible, and then you say, okay, this picture, is it good or not? And that's a human, this is an expert that tells this is good or this is not good. And typically, you have to train with as much as 100 pictures, basically. There are advanced systems that don't even require you to put defects, bad pictures. You can only train with the good pictures, and then the system kind of sees the boundaries of what is good and deduces logically, okay, if I see something that doesn't correspond to this, it must be bad. Okay, so there is even this kind of thing. And then typically you have a response once you have trained the algorithm, which takes, it can take hours or sometimes for the biggest days. Then you have the response in milliseconds, basically. Is once you take a shot, new product, black, ask the artificial intelligence, and you have the reply in milliseconds. Now, for example, we have a startup which is very promising. They have this encapsulated artificial intelligence with kind of an older technology that was used at CERN. It's called RBF neural networks. Older, but enough for many applications and hyper fast. They are in the microsecond time of response. So with this, you can, for example, now you're at the level of sorting grain seeds. You have agricultural companies like Bühler. They have these industrial machines with grain, and they want to select for you and for me, guys, for our breakfast, the best grain with the nice properties. So imagine kilos and kilos of grain falling down, and you need a machine which is like kind of a laser that looks, and the bad ones, it shots and takes them out. And this is super fast, okay? So this is a state-of-the-art kind of technologies. I don't know if I've covered. Yeah. Okay.
Hi, my name is Alex. I've been working in digital transformation consulting for the past 10 years here in Switzerland and globally. Each of the industrial revolutions has so far, if it was the steam engine or the computerization, even brought more jobs overall. But it also increased the stress level and the psychological diseases. So our healthcare costs are really exploding, skyrocketing all over the world. In the US, it's more than $10,000 per capita. So I was always thinking about, don't we need to rebalance our approach to how to actually approach work work hours to actually reduce our stress levels overall, looking at that we always become more efficient, thinking that the computers would actually help us, but in the end we are just processing information faster, and the human brain actually stays the same. It doesn't progress as much as our technological enablers have done so far. What do you think about this rebalancing, also looking at the cost side, not only the revenue side and taxation, the revenue that would this higher automation levels bring, but reducing the cost levels on the healthcare side and others to make also our lives maybe more happier than people being stressed out, working overtime and whatever impact it has.
One comment?
Yeah.
Maybe one comment here. Absolutely. This is an opportunity to rethink the system in a positive way. I'm neither an optimist nor a pessimist. I think everybody agrees that it's a fourth revolution. So we should take this opportunity. But the other danger I can see is that, okay, there will be more jobs, but there will be, as you said, more stress also. Because if you see now, our people are working we are always with our computer, we are always, now everything will be checked more and more. The employer will be able to see exactly where you have lunch, what you have eaten for lunch. I mean, no, but really, it's, there's also the huge problem with these robots that are used now in hospital, for example, for elderly people. Can you imagine the number of data that these robots and the industry has on the health of the patient, on very private issues? There are some psychological issues. Already it was reported that some patients are asking about the fate of their robot. They say, oh, my robot didn't show up today. Is it okay? I hope you didn't destroy it. There are some psychological studies already now. So we should really consider all these issues very carefully, because otherwise you can create a lot of damages at the same time. Psychological damages and stress in work and everything. Yeah.
I really resonate with the word stress. It's a stressful time because of this exponential increment in novelty, and because, okay, we can adapt, we can change our skills, but it might be stressful. And there is a limit. I agree with you. There is a limit as to what we can achieve as humans, right? So I think it's very important, again, this Society 4.0. But we are not waiting for the governments. We are already implementing. I invite you, if you are in Western Switzerland, we are implementing a work group in employability. So I didn't talk of the work of my office, but this was the first work group project that we launched. Before the machine vision program where I'm head, the first one was employability. So if you have an interest, it's really one concern we have.
Okay. Questions for Professor Oberson. On this subject, I think there are lots of questions and lots to discuss. Do you know where this subject is now being discussed, investigated? Probably some societies or discussion platforms in Switzerland or elsewhere. Can you just probably introduce clubs or discussion panels or institutions where we can contribute and our participants can contribute something to this discussion?
Yeah.
I think it's important to make it structured now.
Yes, absolutely. So far, it's very informal. I know some professor working on that in the United States. Also, there's one in Vienna. And in fact, I'm planning to organize a conference in October in Geneva, where we will bring many people, including people from the tax administration. We are going also to think about the use of artificial intelligence, even also to improve the work of the tax administration. So on both sides. So there's going to be a big meeting about this in October. I think 10 or 8. But I could keep you informed. I will keep you informed, of course. But, yeah.
We actually would be willing to co-participate in arranging this, because it's an important subject on many levels, like taxation, society, even philosophical.
Pleasure.
Thank you, Professor. I would like to scare you a bit. I would like to propose some experiment in mind. So imagine I kill myself.
Yeah.
Okay, so, but before destroying my body, totally, with no trace, I take a car that, thanks to computer vision, can be automatic. It doesn't require a driver. So I make this car a taxi. And this car will do its work, get its money, without me. And even it can go fix itself, pay for it, or clean itself, pay for it automatically. It doesn't require even AI. I can do this now without any AI. And imagine even after some time it gets enough money to buy another car. And it may take a year before somebody realizes that I disappeared.